This is a tutorial on using the new interference analysis tool up here in CloudRF. That's the lightning button. In front of us we have modelled an LTE cell in a city on top of a tall building, which is over here. The cell uses 1800 megahertz for the downlink, and the coverage has been modelled as follows using some buildings data. It's pointing west, and you can see the directional pattern over here, and it's very strong over here where there are car parks. Over here in the square we're going to deploy a jammer, a 10 watt jammer, so a fraction, a tenth of the power of the cell, and we're going to model that and see what the coverage looks like. So we've already got that layer in the archive, and let's enable the layer here and switch off the cell and just look at the jammer in isolation first of all. We can see the coverage of the jammer is quite asymmetric because of the large concrete buildings here, so it covers the square easily and it goes down the side street. There's a gap in the square and it's able to reach back to the hospital, which will become relevant in a minute. So we want to see the impact of this overlaid with the cell coverage and see where the jammer is actually interfering as opposed to where there's actual coverage. Because sometimes the cell will be stronger and sometimes the jammer will be stronger. So we open up the interference analysis, we select our signal of interest, which is the cell network, and the jammer or the noise source is the second network. You can also test different networks this way. Click the button and we've modelled interference. The output is measured in decibels with a rainbow color key, where red is bad, so that's bad interference, that will stop you communicating, and green is good. You can still communicate as per the coverage layer that we saw earlier. So let's zoom in and have a look at the results. You can see the square is covered. Well, that was easy. The side streets where the cell tower is weak, they are experiencing more interference from the jammer, and side streets down at street level are also experiencing increased interference from the jammer. At rooftop level, the cell is stronger. When diffraction comes into play, that lends itself to the jammer. So the jammer is able to be stronger in the diffracted areas behind buildings like here, and at the edge of the cell also. So this is a directional antenna pattern, so this is where the pattern is very weak, and this is where the jammer is able to be stronger. So it nibbles away at the cell's coverage at the edges. But finally, the biggest surprise is the hospital itself. This is where the cell is located, right here on this building. And because we have a highly directional antenna pattern, like most cell towers do, there isn't actually strong coverage beneath the cell. And because there's weaker coverage beneath the cell, and we're modelling this jammer at ground level, the jammer is actually stronger at ground level here than the cell, which is a surprise. So that's interference analysis using a 10 watt jammer versus a 100 watt cell, and that is in CloudRF here.